Today's lesson is section 8.2, permutations. A permutation is an arrangement or listing where order is important. So what that means is if there are 20 kids waiting to go on a roller coaster ride and they're randomly selected to start riding, once one kid's been chosen, then there's only 19 kids to choose from now. And once the next kid's been chosen, then there's only 18 kids to choose from. So that order is important, the order at which they've been chosen. So let's say our school offers 23 different enrichment classes each semester. And you are required to list in order your 3 top choices, and they need to be in order of preference. How many different ways could you list your choices? Well, if we go back to the fundamental counting principle, we looked at if you have a coin, and it's a 2-sided coin, of course. And you're going to roll it 3 times. You take the number of possibilities, which is 2, and you multiply it by the number of times you're picking them. And that gives you 6. Okay, so with permutations, things change a little bit. On here, you have 23 options. And you're going to pick your top 3 choices in order. So, I like to make one line for every option you have. This is your first choice, your second choice, and your third choice. How many options do you have for your first choice? Right, 23. Well, now that I've made my first choice, I've closed one of those doors. I have one less option for 22 for my second choice. So my second choice, I only have 22 choices. My third choice, I only have 21 options now. So if I multiply 23 times 22 times 21, I get 10,626 choices. There's 10,626 different ways that we could arrange our course choices. Okay? Let's look at the next part. Permutations can be symbolically represented. The symbol is with the P, 23-3. That's how the permutation that we just worked would be represented. And what that means is there are 23 things, 23 options. And these are basically like your number of seats. The way this words it is it says 23 things taken 3 at a time. I like to call it the number of seats. If you have 23 kids waiting for an airplane, there's 3 seats available. All right. So let's look at this example here. We're using the notation permutation of 9 and 4. So this is telling us that we have 9 things taken 4 at a time. So my 4 slots, my 4 seats, 1, 2, 3, 4. Seat number 1, I have 9 options. I've used 1, so now I only have 8, 7, 6. And when I go through and I multiply 9 times 8 times 7 times 6, I get 3,024. So next, we're going to find the permutation of 7 and 7. Permutation of 7 and 7, we have 7 slots, 1, 2, 3, 4, 5, 6, 7, and we have 7 options, 7, 6, 5, 4, 3, 2, 1. Okay, multiply these all together. You get 5,040 different options. So here, let's go ahead and try number 3 and number 6 on your own. Try them out, pause it, and when you're done, come back and take a look, and let's see how we did. So number 3, we're finding the permutation 8, 5. So here we have 5 seats, 1, 2, 3, 4, 5. We start out with 8 options, then 7, then 6, then 5, then 4. Multiply those all together. 8 times 7 times 6 times 5 times 4, 6,720. Possible arrangements of 8 objects going into 5 different places. Right, number 6, we have a permutation of 101, 3. So there's 101 options going into 3 different slots. You have to choose your first, second, and third choice. 101, 100, 99. 101 times 100 times 99. 999900. So 999,900 different arrangements. Okay, so that is how we use permutations to determine the number of outcomes possible when things need to be arranged and order matters.